put all these pieces together, and this is sort of telling us, putting together the pieces. All right, time for everybody to wake up. This next part, I'm going to show you guys 3 different ways the climate's changed. One of them is happening right now. It's happening really slowly, imperceptible to our citizens. The next example is going to be something that came on pretty quick, lasted for a short while, and then it stopped. And the last one is going to be something that happened basically in an afternoon, and it changed everything forever, and we're still seeing the effects of it today. All right? So the first one are Milankovitch cycles. If you really understand it, y'all need to give me a thumbs up. So with your right hand, give me a thumbs up.
Can I guess what the third one was?
Yes.
Is it Hiroshima and Nagasaki?
Yeah. All right. Thumbs up with your right hand. Fist with your left. All right. With your right hand, cock your thumb out about 23.5 degrees. And then look at what you got.
Asteroid.
Look at your right hand. If you look at it, your thumb, that's the North Pole. If you're looking at it from the North Pole, this is going to represent Earth, and you'll notice how your fingers curl. That's how the Earth rotates. So if you're looking at it from the north, the Earth appears to be spinning counterclockwise. If you flip it over, you notice the Earth is spinning clockwise. So that's how it rotates, and it's tilted. And as we travel around the sun, we're going this direction. So you can kind of stir the pot with me, but keep your thumb pointed the same direction. All right? This is what happens every year. This is what a year is. One lap around the sun. Why is the tilt important? It's what makes the seasons. Okay, so if we're in the northern hemisphere, and we've got the sun here, and we're here, that's going to be winter, because we are tilted away from the sun. Spring, summer, tilted towards the sun. So that happens every year, but one of these cycles happens every 41,000 years, and what that is this. The tilt is less and more severe. How could that changing tilt affect the climate of Earth?
Major.
Sure. So let's crank it to maximum. We're cranking it up to 11. We are the most tilted we are ever going to be. What are our seasons going to be like? How are they going to be different from today?
They're going to be completely different. They're never going to end.
We're tilted more away from the sun, so that's going to cool off our winters. And as we get to summertime, we're tilted more directly towards the sun. So it's going to be hotter summers, colder winters.
That's what's happening. Yeah.
Well, depends on your perspective, right?
Yeah.
Wait, what? Goes around. That takes 24,000 years, and that's not really going to affect our climate very much, but it is kind of cool that our North Star right now, Polaris, is going to change to a star called Vega at about 10,000 years. So that's not constant. But something else that happens is our orbit goes from being almost a perfect circle to an oval, an ellipse. And so when that happens, during part of the year, we are zooming quicker by the sun and we're closer to it, whereas sometimes we go slower by. And that's a cycle that lasts about 100,000 years. But the whole point here, guys, is that there's multiple different ways that are changing at a very slow rate all the time that are affecting our climate and changing it over long periods of time. And we're not really sure what the implications of all of this are, but it's pretty interesting. All right, moving on. Picture of our closest star. What are some things you guys notice? This is taken with a special kind of...
Solar flares.
Yeah, that's our sun.
Wait, what? That's the closest star, Jeff.
It's our closest.
Lightning's hotter than the
What's
sun.
the scientific name for our sun?
Sol. S-O-L. So what are some things you guys notice about this? You talking about like right here?
Yeah.
Yeah. So these things that you see coming off are the same as this little dark squiggle here. They
Solar
are
flares.
freaking gigantic fins of plasma that are held together by the electromagnetic field of the Earth, and occasionally they will open up and send material into
That's
the
bad.
solar system. And if they're pointed right in the right direction, they shoot it at Earth.
And it can blow up our electronics and our whole infrastructure.
Something horrible
It's
almost happened.
happened.
Actually, something that Jed alluded to a minute ago. During the height of the Cold War, when we're on high alert, we're looking for Russia, we're thinking they're going to drop bombs on us, we have to be ready for anything. One day, all of our radios stopped working. So we thought the only possible outcome, the only possible reason is that we're under attack. Russia has launched an offensive. So our military put nukes on bombers, they lifted off and they started flying towards our enemy cities. And while they were in the air, scientists from NASA called up the Department of Defense, and they noticed that there was a lot of sunspots being very active on the sun. And they thought that that might have implications for our communications. So they called up the Department of Defense and told them, hey guys, if there's anything wonky going on with y'all's radios, it might be because the sun is acting up today. We're having a solar storm. And so we like powered down we brought our bombers home and everything. Because we were this close to nuking the world because the sun was acting up on a particular day.
Oh man, that's handsome. Good job.
But here's
We
the
already
thing.
had bombers in the sky around the clock during the Cold War.
Is that afternoon that everything changed? Is that what we're talking
No. I'll let you know
Oh,
when we
I'm
get there.
sorry.
This one is just kind of a segue into our 400 years that we've been 100 years because that's how long we've had telescopes. And since then, we've had these wonderful people who will stare at the sun through a telescope and they count those spots that I showed you. Well, we have filters now that we can use, but originally people were damaging their corneas and their heads doing that. What do you guys notice about our sunspot activity over the last 400 years?
It went up.
Being very active in the 2000s.
Sure, yeah, we get spikes of activity here. In fact, these cycles are happening every 11 years. We have a maximum and a
Aliens.
drop every 11 years. What else do you notice?
Aliens.
Objection.
The joke.
Your Honor.
Wasn't there a CME in 2002?
They happen all the time.
No, not coronal mass ejections, though.
I'm sure they do. They happen.
Yeah, but they would wipe out all of it.
It depends on where it's. So imagine you have the sun, the ball.
Time, but there was one that affected us.
Yeah.
Oh, sure, yeah, for sure.
About cost us everything.
If it happened all the time, we wouldn't have internet. Well, I mean, it happens all the time, but
We wouldn't have. Don't worry about the internet. You wouldn't have a
You gotta
car.
remember too that they're gonna have different strengths.
Yeah.
So some are gonna be weaker than others, and like if you have the sun,
Faraday
your
cage.
Earth, a coronal mass ejection could go that way and it wouldn't affect us.
Or if it's big enough, it could kill us all.
Because look at this. What do you notice from about 1645 to 1715? What's happening with the sunspots there?
Nothing active.
We don't have that many happening.
Is
So-
it because we started making technology?
No.
Oh, okay.
We can't affect the sun like that. But during this period, if the sun isn't as active, what would you expect to happen on Earth as a result of that?
Nothing.
The sun wasn't shooting as much energy our way.
Less life.
That's why. What happened to the temperature?
It was lower.
Lower. Well, it just so happens that in the UK, around that same time, the exact same time actually, during what we call the Little Ice Age, the River Thames froze over. The last time the River Thames froze over completely was 200 years ago. But during this time, it was frozen so thick that they had frozen river festivals and elephants were walking across it. It was frozen for the entire winter and only started to thaw in April, and people only left when the ice actually started to break up, even though there was a bunch of water on the surface. Think about it. A river today that's never frozen over was frozen so thick that thousands of people went out on it. They were doing all sorts of stuff. They had horses and buggies, you had elephants pooping all over the place, walking around. They had shows, fire eaters, all sorts of stuff happening because the sun wasn't as active. Yeah.
Wait, so it's supposed to be like that without climate change? It's supposed to freeze over?
What do you mean supposed to?
Like, if we hadn't affected it like we have, would it still be freezing over?
I don't know. That's a good question. We need to learn more before we can figure that. So this guys is an example of a change that happened relatively quickly, but it took a while to change, the Little Ice Age, okay? The next one, this is your in an afternoon event, okay? And this is one that when I was in your guys' position, when I was in high school, no one knew any of this stuff. The research began in 2007, and we're still learning stuff constantly today. So the stuff that I'm about to tell you is stuff that not a lot of people are even aware of happening, okay? So, once again, astronomy. When we look at our solar system, if we zoom way out of this picture, eventually we get to an area that's like a giant cloud of comets, trillions with the T comets. And they're in pretty stable orbit. They're in kind of like a sphere, but occasionally certain things happen and it can like disrupt their orbit. And those comets will fall into the inner solar system towards the sun. And as they get closer to that star, they break apart. That's what the tail is. And it leaves behind a trail of debris. And as we orbit the sun, the Earth interacts with those paths and makes a, what did you say? A meteor shower. That's how we can predict them, because We know where those paths of debris are. And we know where they're coming from a certain part of the sky, too. And one of my favorites is the Taurids. The Taurid meteor stream happens around Halloween and about 6 months later. And in 1993, during the Taurids, there was a comet called Shoemaker-Levy 9 that was a part of that debris. And it approached Jupiter.
Wait, what?
This is Jupiter. Jupiter is the biggest and baddest planet of them all in our solar system. It sucks in debris from all around it, and a lot of people think it protects Earth from impacts and things that would be really bad for our life on this planet. And in 1993, Shoemaker-Levy 9 was approaching, and the tidal forces of Jupiter ripped it into pieces, into a string, like a string of pearls. Except each pearl is a deadly ball of ice approaching the planet at over 100,000 miles an hour. And when it hit Jupiter, we could see it from Earth, the explosion, with our naked eye, and the explosion itself was bigger than our planet.
Wait, what? How can you?
At nighttime, if you look up, you could see Jupiter, and we could see it get brighter with these explosions happening. And to put this in perspective, one of these fragments, the first large one right here, when it exploded, released more energy than 100 times the world's nuclear arsenal combined at the height of the Cold War. So you're talking Hiroshima, that's nothing compared to what we're talking about here. This
Atomic bomb.
dwarfs anything we are capable of doing right now.
Did it like knock the planet out of orbit or something?
No, I don't think so.
No.
Jupiter is big and bad. It would take way more than this to affect it that way. It's working.
I'd take like,
What would
yeah,
happen
it
if
takes
that
a
happened
massive.
on Earth? Would it just
Well,
be completely
we
all
die.
like
See, that's a
obliterated?
great question, and it's a great segue, because looking at the moon, we can tell that impacts happen, right? A lot of these larger ones are ones that we think happened as the moon was forming. But some of the smaller ones, like this one, Tycho crater, that one happened, we think, about 65 million years ago. What else happened on Earth roughly 65 million years ago?
The dinosaurs.
Dinosaurs died, right? So, how did the dinosaurs die? We think it impacted them.
Is there like so is that what most people believe, like most scientists believe?
Yeah.
Is a meteor?
And let's see why we think
We
that.
know.
So some of the times when things in our solar system, and when we see like meteors and stuff coming in, they burn up in the atmosphere, they blow up, they don't actually get to the ground. And it has to be pretty big to actually get to the ground. But a lot of comets, especially, they're not that dense, they can't make that trip through our thick atmosphere. And so they will blow up in the air. We call them bolides. And one of those happened, once again, part of the Taurid meteor stream in 1908 in Tunguska, Russia, which is like a really remote part of the area. Not a lot of people were there to see it, but there was one guy, a farmer, that lived pretty close
It
by.
blinded him.
He was telling a story about how he was sitting in a chair in front of his house and he was getting drunk. And he felt a really, really hot sensation on the back of his head. And then he woke up a few meters away. Because this impact blew up right by his house. And when I say right by, I'm talking like miles and miles away.
And the
When
shockwave
this
got
thing
him.
hit, it leveled almost every single tree in an area 5 times bigger than Chattanooga inside.
It's outward.
So
500
just think
miles.
about what that would do if it blew up over a city today.
I know we learned about space.
We are learning about space, and that's why I love climate science. I love it. So this happened in 1908, but something much bigger happened 65 million years ago, and we know that it was an impact because we find evidence for it in the rocks.
Literally
Okay?
everywhere.
This layer right here, we call the KT boundary, or the Cretaceous-Tertiary boundary, and it's special because below this layer, we can find all the skeletons of all the dinosaurs that used to live. But above that layer, we find none of them. They all died during that event. I mean, some of them, like the smaller ones that survived, and now they're birds, but most of the big ones, they all got wiped out. And when we started to really pick apart this layer and learn about what was in it, we found some interesting things. Some of the stuff we found were tiny little hexagonal nanodiamonds that can only form, that we're aware of, in impact events in like really high pressure, high heat, high energy environments. What's up?
Sorry if I'm asking too many questions.
No, go
but,
for it.
isn't there like a huge crater they found where they're pretty sure is where it hit?
Mhm.
I'll show you where that is.
I know what
Yeah, no,
Utica.
you're good. I love it. If you guys have questions, please ask. That's why I'm here.
Have
Have you seen the recent discovery that they made of a fully, like, completely preserved feathered dinosaur tail in amber?
Yes.
So
It's
cool.
pretty awesome. I mean, before that, I mean, look at this picture. No feathers. And that's how it was like my entire life. And now we're starting to realize that these things are more beautiful and different than we ever imagined. So it's really special. But in this layer, we found your phones and computers. It's called iridium, and it's a rare earth element, but it's not rare for asteroids and interstellar objects. And so whenever we find a layer and it's rich in like iridium, but above and below it's not, we know that an impact or something from space came to Earth. No, what's up?
Have you heard of the Maryland crater right out in the bay? It's literally right off the bay from like I think DC.
No, I haven't.
It's like not very many people know about it, but there was an asteroid strike like 3 miles from like DC, I think.
If you can find that later, will you email me able to?
Okay.
Wait, I thought the crater, they thought that was related to the extinction of the dinosaurs in South Mexico.
Yes, that's the Gulf crater.
It's kind of, if I were to major in astronomy, it would be mostly
Geology.
math, right?
There's a lot of math involved.
I wanted to.
But depending on,
Already
if
got
you're
it.
interested in learning about it, but you don't
Testing
necessarily
thing.
want to like get into the math thing, we can talk later and I'll tell you about some potential jobs you can have that would help you learn about it and be able to use it in your life without needing to get into like astrophysics and rocket
Exactly.
science.
There's a lot of like.
The cool part, not the hard
Yeah. So anyway, I'm gonna go a little bit different direction here, and I want to ask you guys if you've ever thought about why there are no big mammals in North America. I'm talking like elephants. I'm talking pronghorn. I'm talking lions, stuff like that. Why aren't they here, but they're in Africa? Because what? It's not warm enough. I don't know about that. Like, mammoths and mastodons live in some pretty cold climates.
Pretty tasteful. They have fur.
What about cheetahs too? Well, I'm here to tell you that they used to live here. This is a picture I took in California. These are tracks that are about 2.5 million years old, and they're about 1.5 times the size of normal, everyday, today lion tracks. And we found them in California. These belonged to, at one point in time, saber-toothed cats. Also, in that same canyon in California, we found tracks that belong to mastodons, or the relatives of elephants.
Whoa! And that's just there?
That's
Like you
there.
didn't have to do any digging or anything?
No. So, there used to be 13 species of elephants that lived in North America, 7 of which lived in Tennessee, and now there are none.
Have you found any fossils of them here in Tennessee? Oh, wait, you said camels,
In
right?
Tennessee, I don't know, but definitely in Arizona.
That's
and
actually
Mexico.
probably my brother question.
Camels, there's camel track. That picture I took in California from 2.5 million years ago, the camels walked through there. Horses. Horses also used to live in North America. And this is like, I'm going to get into this in a second. What's up?
How do you know that those are 500,000 years old?
So that's a great question. 2.5 million years. We look at the strata and we can put it together like, so in this particular part of the world,
It's reserved.
there were, it's like savanna in Africa. The way that the climate is there, you have a dry season and a wet season. It's not so much winter or summer. And during the dry season, it's all mud and like caked dry mud, like kind of what we see here. But in the winter, during the rainy season, mud gets washed in and it fills in over those layers. And so what these are from is camels walking on the mud, and then it hardened during the dry season. And in the wet season the next year, there were floods that washed mud on top of it, and then other animals walked on top of that. And we can kind of reverse engineer how those layers were put into place and the different giant blocks of strata. And I don't know exactly how they dated it back to exactly 2.5 million years ago, but it's pretty sound dating. It's well agreed upon in the geological community.
That
So let's talk
crater's
about
in
horses for a
Chesapeake
second.
Bay.
I used to live in Oregon right next to this park called John Day Fossil Beds National Monument, and one of the things that they do there is they research evolution of animals. And the reason it's a really great spot to research that kind of thing is because it was really volcanically active. And so you have like, imagine there's this area, it's like really fertile, lots of animals living, thriving, mating, dying, all that stuff. And then volcanic activity came in and they were all choked out with ash and everything died and they were all buried. And then slowly it's recolonized by lichen and plants, things come back, more animals come in, they live, they reproduce, they thrive, and then another volcanic eruption. They all get buried in ash and die. And this happens over and over and over again. And what the scientists there have dug up is 55 million years worth of horse evolution. Back from the time when they had 5 toes and each one had an individual hoof on it, and pretty soon they lost a couple, they had 3 toes and each one had a hoof on it, and then later they had one giant toe that they walked on. Back to horses like we see today, but 13,000 years ago, they all disappeared in North America. They all died. They lived here for 55 million years, and they all died 13,000 years ago, and were reintroduced 500 years later by the Spanish. 500 years ago, rather. To put that in perspective, if that 55 million years is your life as of right now, the horses all got wiped out 3 minutes ago. It was really recent. Happened like yesterday. So what happened to these animals? Here's one that isn't around anymore, and I'm glad. It's the short-faced cave bear. These guys were 6.5 feet tall at the shoulder. They weighed about 3,000 pounds. They could run 40 miles an hour, and they only ate meat. We call them hyper-carnivores. That assembly we had this morning, we wouldn't have been able to have that if short-faced bears lived around here still today. And they lived in Texas. I don't know how people would have dealt with that animal.
Where is the nearest like
guns.
fossil found from here?
I don't know. Most of them that I have seen have been from the New Mexico, Arizona area, but that's just because I used to live down there, and I went and checked it out. But they used to live here in Tennessee too. What's up, Noah?
Well, my brother's a federal geologist for the U.S. Department of Energy in UGA. He's under UGA. And when we went to Rome, he was like, take one look at some of the seven wonders of the world. He's like, oh, that was built like yesterday in geology, and it just made me laugh. So.
No, this is true. I mean,
Yeah.
long periods of time aren't really that much at all. So, we have the dinosaurs. We found the KT boundary. We know that they died from an impact event because we found the evidence in the rocks. We look back. Here, there were 13 different species of elephants. There were a bunch of different kinds of pronghorn. There were giant sloths that wouldn't fit in this room because they were too big. All sorts of these animals, they all died out 13,000 years ago, and it just so happens that there's a layer that's almost exactly the same as the KT boundary we call the black mat layer. Below this layer, leading up to it, are all the skeletons of those animals that used to live here that are now dead. And above it, none of them. None of them. And when we start to look at that black layer, it's black because there's a lot of carbon in it, but we pulled out all the same exact things that we found in this layer that tell us that it's from an impact event. This was basically yesterday, guys. If we look at long periods of time, so far right side of the screen is 22,000 years ago, you'll notice you got some climate fluctuations, some temperatures, but then we're coming out of the coldest part of the ice age, which was like 16,000 years ago. We're climbing out of it. We get almost all the way. We're at a warming period that's comparable to temperatures today, but then it plummets. And the biggest drop happens right here at the exact same time that we find all this evidence for an impact. The climate globally changed. The temperature dropped about 20 degrees Fahrenheit everywhere, basically overnight. Yeah.
Wouldn't it heat up?
Well, see, here's the thing. I'll tell you why it cooled off, but we have a warming spike here that's unexplained.
Oh, I see.
Unexplained. So, my hypothesis, and that's just a guess, is that there were probably 2 impacts. One of them happened 13,000 years ago, and that's the one that cooled off the climate. It stayed that way for 1,200 years, and then maybe there's another one or something to heat up the climate equally as drastically, equally as swiftly, too.
What could have been like a volcanic explosion that locked the
Yellowstone.
What caused the planet down rather than an impact?
I'll show you why,
I know which one.
or how, rather, an impact
Sorry.
could cool the climate. By the end,
I
if you
know
have-
it can, but it just seems like a little bit less likely than.
I'll show you the evidence in the meantime.
Okay, that makes sense.
Okay.
Sorry.
No, you're good. One of the things that we looked at was different areas that has that black mat layer exposed, and all those different sites, we found the exact same thing. The exact same time, were laid out the nano from an impact event. So all this stuff is lining up perfectly to this time about 13,000 years ago. And the coolest part is when we started flying into the air and started looking down at the ground from above, and we found these. What are these? Craters? How deep do you think a crater like that would be? By the way,
A mile.
One of them is about a mile wide.
Got 'em.
How deep would they be?
A
Just have
mile.
a guess.
0.5
A mile.
miles deep.
1 foot.
I'm-
So we were walking on top of them. Some of these, I don't know if you can see those lines, those are from farms, from crops, people planting on these things. You could literally be walking through the forest and step over a 1 foot tall ledge, and you'd be stepping over the rim of a crater and walking in it and never know. And we only discovered these when we started to do laser scans of the surface.
LiDAR.
A LiDAR.
How
Yeah, I
high
want to
up
do
is
that here.
taken, do you know?
I don't know.
That's
But you
expensive.
can see,
Is it really high up?
here's a valley,
Okay, yeah.
right? And each one of these is 1 mile wide, so that kind of gives you the context there. But what do you notice about all of these craters? They all have something in common.
They're all
Oval. They're all oval, which means that whatever hit came at an angle. What else do you notice?
It's in a shotgun pattern,
Oh, they're all kind of like
close
Like-
together.
lines.
They're pointing in the same direction, right?
Yeah.
So we found these in all of these places, and all of them are pointed towards Hudson Bay and Greenland. All of them angle that direction. And what's more, when we actually found these, we started to sample the edges of the craters, and we found that there was material that dated back to about 13,000 years ago, and it had all those impact proxies in it still. So here's our impact. Should we be able to find the crater for the object that entered the atmosphere? As of when all this research was done, we had not found it, unfortunately. But we found it 2 months ago,
When was the research started again?
2007. So, all right, here is Earth. And zooming in here, so the asteroid that killed the dinosaurs impacted somewhere around here near the Yucatan.
Part of it's in the ocean and part of it's in Yucatan.
And I don't know exactly what to look for to find it for y'all right now, but maybe if we have time when we're done, we can look at it. But let's look for a minute at why, to answer your question about why it would cool the climate. Okay. So we have an impact coming from Greenland. It rains death and destruction down upon North America especially. But when that happened, all of Canada was covered in like 2 miles of ice. Okay? Now what can you tell me about our climate in Tennessee and the number one thing that gives us a warmer climate with more moisture?
Jet stream.
The ocean. The what?
I said the jet stream.
Well, the jet stream is in
Yeah.
the sky, but we have
I'll know
oceanic
it.
convection currents, right?
Yep.
And they are caused by an uneven heating of the equator, making water
You're right.
flow on the surface warm, carrying warm water up this way and up this way, and then from the poles, cold water circulating down. So it's like a conveyor belt. It's flowing constantly.
That's where the
I
crater is.
wonder why they didn't start research until 2007, because I remember reading about
Yes.
Shoemaker Levy 9 like a long time ago, and, you know, that could have been catastrophic, and it just kind of just brushed off. And then there was another event where, I can't remember what it was called, but, there was like an asteroid that came closer to the Earth than the Moon in like the early 2000s, but like before 2000, I think it was like 2005. And like, this,
I think part of
I
it
mean,
is it scares people.
yeah, I mean, and I know it would take probably more than 2 years to really get the research set up, but still, like, it has I forget the name of it, it's like a couple of numbers, and that's what the name of it is, and it's supposed to do another relay in the next 200 years.
Well, we
And
won't be
it's
around.
supposed to come even closer, which is a little bit
So
disconcerting.
anyway, I just want to play this situation out for you guys. So impact event up here, rains, superheated, ejected down, melts that ice cap. All this water that was ice, trillions of tons of ice, gets dumped into the ocean. And when that cold, fresh water gets dumped into the ocean, it disrupts the ocean conveyor belt. The
That
Earth
makes
can no
sense.
longer cycle the heat around, cools the climate down
Yeah.
substantially. And the comet crater, or the asteroid crater, is in Greenland. And it
Is
is
it that indent right there across like a heart?
Right
Or is
here.
that- Oh, no, okay. I think it cool too, because it looks like a heart. You're really wrong.
right here. They call it the Hiawatha crater, and we found it by using ground penetrating radar, or ice penetrating
GPR.
radar. And what they found was the crater is about this big,
I can see it.
and it has drainages, ancient drainages that go this direction, back when there wasn't as much ice. And the dating isn't like super secure yet, because they only found it 2 months ago, but The oldest ice that they found is about 13,000 years old. They
Hit
haven't found
3D.
any ice older than that. So that would,
Oh, how can you age ice?
you can age ice with oxygen isotopes. There's two different types of oxygen you can find freely in the atmosphere and the water of Earth. Oxygen 16 and 18. Oxygen 18 has 2 more neutrons, so it's a little heavier. And so what happens is it will settle down into areas, and when we have times of colder climate, you find more dense concentrations of that in the oceans, and because all of the other stuff evaporates and is locked up in ice on the continents. But it has to do with oxygen isotopes. And that's one of the ways that we know we can kind of put together ancient climates with the Greenland ice cores. That and carbon dioxide are the 2 big ones that we get from water anyway. Because this happened basically yesterday. This happened 13,000 years ago. It changed the world forever. It happened in basically a single afternoon, and we're still seeing the impacts of it today. It's the reason why we have the animals that we do in this part of the world, why all the elephants and things died from North America, why the horses disappeared, and why there's a huge crash in the human populations. Humans disappeared from California for 1,000 years after this happened. And we know that because we looked at quarries where they harvested things to make arrowheads and spear tips and stuff. And they just stopped being used for like 1,000 years. And today, what's even more interesting is as this ice continues to melt back as our climate heats up, we are finding ancient artifacts with people that lived there when it wasn't covered in ice. We're finding fully intact spear tips, atlatl spears, all sorts of stuff, which tells us the climate used to be hotter than it is right now, and that it cooled off drastically, enough to make other glaciers. Pretty cool. Do you guys have any questions or anything more?
So it's the Chesapeake Bay crater. It's partly on land. You should go and use Google Earth there. It is
Bay crater?
basically partly in the water, and it basically said it could be seen from like 8 states, basically.
Do you know if you can see it from space?
Probably with LiDAR you could.
Yeah, I don't think we're gonna be able to see it from Google Earth.
I read something recently that I think in like the 2020s NASA's gonna launch a new satellite that's specifically supposed to track near Earth asteroids and near Earth comets. I feel like that would be really difficult though because the Oort cloud supposedly surrounds a sphere. It's like, I mean, that'd be very hard to track all.
You know what the
It
real
would
scary
be-
thing is?
I don't know how.
True. No, I
You know, I feel like that'd be really, I think it's really fun.
You never know.
We've got a blind spot too. We can't see stuff coming from behind the sun. So there could be something right there. and it'd be
Never.
obvious that we just
We'd never know it.
I mean, some people, there's even like an idea, which, I mean, I know they're not gonna do it, cause I mean, this would make things harder, that they were gonna try to